Hey everyone, welcome back to my YouTube channel. Myself Janavi MS from the Department of the Computer Science and Engineering. Today we are gonna discuss the topic is properties of subgroups and subgroups in discrete mathematical structures. Let us see introduction to groups and subgroups. In discrete mathematical structures, a group is a set equipped with an operation that satisfies four properties: closure property, associative property, identity element and inverse element. A subgroup of a group is a subset that forms a group under the same operation. The study of a group and subgroups is fundamental in various branches of mathematical, including algebra and combinations. Closure property of groups. The closure property states that any two elements A and B in group G, the operation A, B is also in G. This property ensures that the group operation is well defined and the combining element always results in another element within the group. Associative property of groups. The associative property states that for any three elements A, B and C in group G, the operation is associative. Your second bullet C is equal to A. Identity element in groups. The identity element denoted as E is an element in a group G such that for any element A in G, A is equal to A, E is equal to A. Inverse element in groups. The inverse element of an element A in a group G denoted A is an element such that A minus 1 is equal to A minus 1. A is equal to E, where E is the identity element. Subgroups and their properties. A subgroup H of a group G is a non-empty subset of G that forms a group under the same operation in G. Subgroups inherit the closure, associative and identity element and inverse element properties from the parent group G. The study of subgroup allows for an analysis of smaller, more manageable structures within the larger groups. Criteria for subgroups. To show that the subgroup H of a group G is a subgroup, it must satisfy the following criteria: closure under the group operation, containing the identity element and containing inverses. The subgroup must also be closed under taking inverses, ensuring that each element inverse in allow within the subgroup. Verify this criteria is essential in establishing a subset from a subgroup of a given group. Types of subgroups. Proper subgroups are subsets of a group that are not equal to group itself and contain at least one element different from the identity element. Trivial subgroups consists only the identity element and are always subgroups of any group. Non-trivial subgroups contain elements other than the identity element and form distinct structures within the parent group. Generating subgroups. A subgroup generated by a subset S of a group G, the smallest subgroup of G containing all elements of S. The subgroup generated by S, denoted as S, consists of all possible finite products of element from S and their inverses. Generating subgroup allow for exploration of the relationships between elements in a group and provide insights into structure of the group. Lagrange's theorem. Lagrange's theorem states that the order of subgroup H of a finite group G divides the order of G. The order of a group is the number of elements it contains. The Lagrange's theorem provides a powerful tool for understanding the structure of the group and its subgroups. This theorem has application in various areas of mathematics, including cryptography and coding theory. Cosets of subgroups. The left coset of a subgroup H in a group G containing an element G is the set GH is equal to set of GH is H belongs to H. The right coset of a H containing G is the H set HG belongs to HG. H is belongs to H. Consists partition the group into sets that play a crucial role in understanding the structure of groups and subgroups. Normal subgroups. A normal subgroup H of a group G is normal if for every element G in G and every element H in H, the element G H minus 1 is also in H. Normal subgroups are invariant under conjugation by element by the group and they play a significant role in quotient groups and group homophones. The concept of normal subgroups is essential in the study of groups theory and its application in various mathematical fields. Quotient groups. A quotient group, also known as a factor group, is a group obtained by partitioning a group G by a normal subgroup and defining an operation on the resulting cosets. A quotient groups provide a way to study the relationship between a group and its normal subgroups, capturing essential information of the group structures. The fundamental theory of homophones established a corresponding between homophones and kernel of groups homophones, highlighting the significance of quotient groups. Isomerism theorems. The first isomerism theorem states the isomerism pi from a group G to the group H. The kernel of the pi is normal subgroup of G and image of the pi is isomorphic to the quotient group G by curl or pi. The second and third isomerism theorem provides the insights into the relationship between the subgroups, normal subgroups and quotient groups, offering powerful tools for analyzing group structures. Isomerism theorems plays a crucial role in connecting different aspects of the group theory and facilitating the study of groups and subgroups. Direct properties of groups or direct products of groups. The direct products of two groups G and H denoted G into H is a group whose elements are paired GH. Write the group operation defined component wise. Direct products allow the construction of a new groups from existing groups, preserving the individual structure of original groups. The direct product is fundamental concept in group theory, enabling the study of groups with diverse properties of interaction. Direct sums of groups. The direct sum of alien groups G and H denoted G plus H and group O's element the pairs GH with the group operation defined component wise. Direct sums extend the concept of the direct products to abelian groups, providing a way to combine groups while maintaining their element structures. Direct sums are widely used in algebraic structures and provide versatile tools for the studying the properties of groups and subgroups. Automorphism of groups. An automorphism of groups G is isomeric from the G to itself, preserving the group structures and operations. Inner automorphism and automorphism include by conjugation by element of the group, while outer automorphism are introduced permutation group element play a crucial role in understanding the symmetric transportation of the groups, offering insights into the inherent properties of a group structures. KLS theorem. KLS theorem states that every group is isomorphic is a subgroup of a system symmetric group. The theorem provides a powerful representation of groups in terms of permutations, highlighting the connection between the group theory and combined groups. A KLS theorem demonstrates the richness and universality of group structures, showcasing the diverse way in which groups can be studied and understood. Applications of group theory. A group theory has a diverse application in various fields including cryptography, physics, chemistry and computer science. In cryptography, groups are used to design secure encryption algorithms and protocols based on the properties of groups and the subgroups. Conclusion: the study of groups and subgroups in discrete mathematical structure is essential for understanding the fundamental properties and structures of mathematical systems. Properties such as a closure property, associative property, identity element and inverse element define the structure of groups and subgroups, providing a framework for analyzing their properties and relationships. By exploring the properties and interactions of group and subgroups, mathematicians uncover profound insights into the abstract structures and handle various mathematical phenomena. Thank you.